Hey, what's up? Welcome to the sexiest channel on YouTube, that's for sure. Um, Today, I'm gonna be talking about decimals and how you can perform calculations like multiplication, division, addition, subtraction with decimals, because that's different from whole numbers. So, let's go. So here's the thing. Basically, as we already know, decimals are the same as fractions. I'm going to cover that. For example, 0.3 is the same as 3 over 10. I'm not going to cover that for now, but let's just go straight to it. So let's go with addition and subtraction. The key thing there is that we only care about aligning the decimal point of each value of an expression. So for example, if we have 3.24 plus 69,420, in here we just care about aligning the points. So in this case will be 3 point, because it's aligned, 24, and on the spaces like this one and this one we just add zeros. So 0, 0, and obviously you perform the calculation. I mean, yeah, I'm not gonna go beyond that because we already know how to perform calculations this way, right? But basically that's the key thing we gotta understand. That's, you gotta just simply align the values. Okay, now there's another key point that we gotta understand, and that is that whenever we are performing calculations that are different in signs, so for example in here we both are, this is basically a sum, they have the same sign. Let's say that we have minus 3.24 plus 69,420. So in this case, this is a calculation where we have different signs, the negative value and the positive value. In this case, whenever we have different signs, we always need to add for the highest value at the top. So in this case, this is the highest value, and we need to add it to the top. What do I mean by the top? Well, yeah, like for example, this is the top, this is the bottom. Because and the reason why this is so key is sometimes people do this. So for example, sometimes people do this, and then they do 69 plus 420. Sometimes they do that, and that's not the right way to do it, simply because you're not going to get the right result. So that's another key thing. You gotta always have the highest value at the top, no matter its sign. Like for example, here is a plus, but if it was a minus, it doesn't matter. Whenever, yeah, you're performing addition or subtraction of an expression that contains different signs. If this was minus 3.24 minus that, doesn't matter. It's the same as an addition, right? Yeah, that's a key distinction. So yeah, I think those 2 points are like the primary points about this, about performing calculations with decimals. And yeah, let's go to multiplication and division. Now let's go through multiplication. So for example, in multiplication, let's say we have, well, first things first, in multiplication we don't really care at all about aligning the decimal point, just like we did on addition and subtraction. In this case, let's say we have 3.25 times 243.2. In this case, 0.25, as you can see, they are not aligned, like they're like this. Like, we don't care about that, okay? So in here we just care about actually performing the calculation, which I'm not gonna do because we already know how to do that, right? Times 2 times 3.25. So that gave us, sorry, that gives us this. After performing the calculation that we already know how to do, that gives us this. Now, the key thing here, and this is a key thing, is now counting the place, like the decimal places of each value. So counting the decimal places of this value and counting the decimal places of each value. Then we combine those decimal places, and by combining it, we're gonna know what is there's what how many we're gonna know how many decimal places will the result have. So for example, we have in here 1, and then we have here 1, 2. In total we have 3. So in this case we're gonna have 3 decimal places on this result. So that will be 1, 2, 3, boom. So then the answer is 7 point yeah, sorry, yeah. So that's the answer. And I don't know why it's not working. The fuck? What is happening? 1, 2, 3. 1, 2, 3. Man, shut your bitch ass up, man. Okay, let's do it again. Okay, so let's perform the calculations. So there you go. Now we just so there you go. This is the result that we have. And now the key thing here, the key distinction in here is that we need to count the decimal places of both values, of both factors. In this case, 1 in this value, and 1, 2 in this other one. That means 3 decimal places in total. And that means that the result is gonna have 3 decimal places. So in this case, that means 1, 2, 3. So the decimal point now goes here, and the result is this. So the key thing here is not aligning the decimal value, but rather counting the decimal places of each value, and then the result of that count will be how much decimal places will the result have. Okay, so that's the thing. And the reason why that is the case is because you are multiplying decimals, and I don't even know the reason. No, I honestly don't know the reason. So that is the case, okay? That is the key thing. And same with division. Now in the case of division, there's already a lot of ways in which we can represent division, like this, like, it doesn't matter. The thing here is that we always do it by hand this way. So for example, if we have 3 divided by 2, here this is the divisor, this is the divisible, so the divisor is gonna go outside. In this case, and 3 we're gonna go here. Okay, for example, this one boom, boom, and then we have here, boom, and then we have here, boom. So that's how you solve it. Now, we don't care about whole numbers, we care about decimal numbers in here. So let's say we have something like 2.3 divided by 34. Yeah. So in this case, sorry, by 3.4. In this case, we have 3.4 here and 2.3 here. Now, this is the key thing we gotta do. This always needs to be a whole number. So whenever this, which is the divisor, is a decimal, we need to convert it into a whole number. That's the first step we gotta do. Why? Well, because that's how it works. Like basically all of these procedures that you're looking at, for example, this way of representing a division in which is like a box, is just a way in which is easier for us humans to understand. Same with this, right? It's a much way easier. Yeah, it's just way easier for us humans to understand. So the rule naturally follows that in order for that to be easier to understand for us humans, like we gotta convert this into a whole number, because whole numbers are easier to understand for us humans than decimals. So in this case, how do you convert a whole number? Well, here's the thing. You're gonna move the decimal place to into here in order to get rid of it. So, and the other thing is that the same amount of decimal places that you move in here, you also got to do in here. So it's kind of, it's very, like, it reminds me of what's required when you're solving by x. So for example, when you do something like this, it's very similar. Like in here, you need to align and you need to keep this equation balanced. So in this case, what you do is, since it's multiplying, you divide and you do the same thing in here in order for this whole thing to stay balanced. So it's kind of a similar analogy in here. What you do in here, you do also in here. So obviously it's different. So in this case, we move it and it's got 34. Now we got a whole number, which is more easier to understand than a decimal. And in here, we also have 23. And well, you then just solve it, right? So that's the key thing, that you gotta basically make the divisor go from a decimal to a whole number. And yeah, that's basically it. That's basically how you solve multiplications, divisions, additions, and subtractions with decimals, which are way different than whole numbers. So yeah, there you go.